Hello everyone. This episode we will talk about linear and Bernoulli ODE. And I promise you this episode will end sooner than previous ones. Here we show you the definition of a linear ODE, including homogeneous linear ODE. The expression is like this. And there is also non-homogeneous linear ODE. The expression is like this. You can pause the video and observe for a while until you figure them out. When we translate a physical situation into a linear ODE, the R of x often denotes the input and Y of x often denotes the output. For example, if R of x is a force, then the Y of x will be the displacement. The idea of solving the ODE. Once you sow the seed, the plants will grow naturally. The seed, in this case, is an idea that you should bear in mind. It might take you some effort to bear this idea in mind, but once the seed is sowed, the plant will grow naturally. So when you're solving an ODE, once you apply the idea in your mind, then the subsequent calculation will develop very smoothly. So in the subsequent slides, we will especially highlight those seeds in the calculation of the ODE solving process. In this slide, I want to demonstrate the process of solving a homogeneous linear ODE. This is a homogeneous linear ODE, and you can reshuffle the terms in a way that all the y terms on the left side and all the x terms on the right side. And this is called separating variables. And this is the action of seeding that I was talking about in the previous slide. So once you remember the idea of separating variables and apply it in the solving process, whenever you encounter a homogeneous linear ODE, then the subsequent calculation will develop very smoothly. You can pause the video and observe for a while until you figure them out. I don't wish to elaborate the process. Of course, you need to have some basic understanding and calculation skills in order to solve this ODE. Now I want to demonstrate how to solve a non-homogeneous linear ODE, and we'll also particularly highlight the action of seeding, which is the crucial step in the solving process. Once you have taken this crucial step, the subsequent calculation will develop very smoothly. So this is the non-homogeneous linear ODE, and it cannot be solved by separating variables. So you need to find f as integrating factor and multiply the ODE by f. So the purpose is to solve the ODE by simple integration. In order to do that, you have to make the left side of this expression, which is the fy prime plus pfy, a perfect result of differentiation of fy. In such doing, you can solve the ODE by integrating both sides of the expression. So in order to satisfy this condition, you have to make PFY equating to F prime Y. And you can cross out Y on both sides of the expression. And separating variables, you get this expression. And obviously, it is integratable. So you can solve F. At this stage, you can pause the video and observe the detailed calculation. And since we already find F, which is equal to the exponent to the power of h, so we multiply the ODE by F. So at this stage, you get this expression. Then you can reorganize in the expression, and so you get this expression, and by integrating both sides of this expression and reshuffle the term, the exponent to the power of h, to the right side of the expression, thus you get y of x. So the conclusion is that you have to keep the this crucial step in your mind. This is what I call the action of seeding. Once you sow the seed, the subsequent calculation will grow naturally by basic knowledge of calculus skill. In the previous episode, we have elaborated on and visualized the process of finding f, the integrating factor, for an implicit function u of x and y equates to 0. And in this episode, we have demonstrated the process of finding f for an explicit function y prime equates to f of x and y. The ideas are different because the structures of these two functions are different. Let's refresh our memory. U of x and y equates to this one, and multiplied by f in order to solve the ODE by simple integration. The exactness condition has to be met, and all the subsequent calculation will be derived from this exactness condition. And once you have taken this crucial step, which is what I called the action of seeding, the subsequent calculation will develop very smoothly. Of course, you have to choose one of the two paths, whereas the corresponding premise has to exist, so you can solve f. And for finding f for the explicit function y prime, we just learned from the previous slide that the action of seeding is this one. You have to set PFY equating to f prime y, hoping that the left side of this expression, which is fy prime plus pfy, is a result of the differentiation of fy. So you can solve f by simple integration. So you have to learn that what is the seed, what is the crucial step for the implicit function, and what is the crucial step for the explicit function, and you have to keep those seeds in your mind, and thus you will make solving the ODE very smoothly. And now we want to introduce a kind of ODE which is called Bernoulli equation. Bernoulli equation has the following form. It's quite similar to the linear ODE, except that the input term has to be multiplied by y to the power of a in order to transform this Bernoulli equation to a linear form. We have to take the crucial step, which is what I called the action of seeding, by setting u of x as y of x to the power of 1 minus a. Once you have taken this crucial step, the subsequent calculation will develop smoothly. The detailed calculation is omitted here. Therefore, the converted Bernoulli equation has this following form. And logistic equation is a special case of Bernoulli equation, whereas a equates to 2. Likewise, we also want to reduce this logistic equation to its linear form by taking this crucial step, setting u of x equal to y of x to the power of minus 1. So once we have done that, we can solve u. And by setting y equals to the reciprocal of u, we can solve y. Logistic equation plays an important role in population dynamics, which is a field models the evolution of population of plants, animals, or human. This is the expression of the logistic equation, and this is the form of the solution. And you can observe that minus by squared is the breaking terms, which prevents the population from growing without bound. So if we set b as 0, y will become an exponential growth function, which simulates a situation where a small group of people live in a big country. And furthermore, when time approaches infinity, this term will diminishes, and y will become a over b, which is the limit of the population y. If we arrange this equation into this form, we can predict the trend of the population by simply observing this mathematical expression. For example, if y starts somewhere below a over b, the population will enjoy a positive exponential growth, and it will stay that way until it reaches the limit. And during the process, as the population y gets larger, this term will get smaller, and also the momentum of the growth trend will also decreases until it reaches the limit. Likewise, when population Y starts from somewhere larger than A over B, the population will be an exponential decay function, and it will stay that way until it reaches the limit. And during the process, as the population Y gets larger, the momentum of the decay will also decrease. So for me, the most beautiful point is that you can totally predict the trend of population by simply observing this mathematical form. The proportion of A over B determines the limit of population, and by observing this mathematical form, the population will be an exponential function, and the starting point of the population will determine whether it is exponential growth or exponential decay function. And also, judging by this term, no matter it is exponential growth or decay function, ultimately the population will reach its limit. Finally, coming to our takeaway points, I want everyone know that once the seed is sowed, the subsequent calculation can develop naturally based on your basic calculation and other calculation skills. Of course, if the ODE problem requires you some more difficult calculation skills, then that would not be our concerns for now. So please keep the seed in your mind. Okay, I hope we will see you very soon. Bye bye.